Okay, so today this is we're going to look at reviewing some stuff and maybe extending it very slightly. So this is pretty straightforward, not real complicated. We're going to look at how we graph, first of all, how we graph linear inequalities in two variables. And then after that, we'll take a look at what happens if we have a system of linear inequalities in two variables. Okay, so first of all, quick review of how it is that we graph something like this. You know, y is less than 2/3 x minus 1. You probably remember this stuff, right? Really what it always is going to consist of is a boundary line and a shaded half plane, okay, every time. So the boundary line is just the line that we would get if we replace the inequality with an equal sign, right? So in this case, we've got the line, the boundary line is the line y equals 2/3 x minus 1. So let's graph that. What does that look like? How am I going to graph that thing? Where do I start? -1. Okay, good. We got a y-intercept of -1. And we, from there, what do? Rise 2 and run 3. Okay, good. So we're going to rise up by 2. We're going to run over by 3. And we get another point. Now, how do we graph this boundary line if there's no equal sign included in our inequality? Do you remember? Ashton? Oh, you have a -2/3? Oh, okay. Well, let's change it. So this is -2/3 also. How about it? Okay, let's make that -2/3. So that's going to change our picture a little bit, isn't it? It's less than or equal to? Oh, that's probably it. Yeah, I think that's it. So right, and this isn't from the new notes. This is from the old ones. So I'm going to leave it like this, I think, because I think this is from the 2.6 part A, the one just on inequalities. Okay. So now, how do we make this? Do you remember? Give me just a real quick sense. Is this looking familiar? Give me a 1 to 5 on how well you think you remember this stuff. 5 meaning I remember this stuff completely. Okay, so pretty good. All right, we're pretty much there. So how do we graph the boundary line then? If there's no equal sign, what's the rule? Okay, it's going to be a dashed line or a dotted line, isn't it? Right? Because what's that tell us? It's merely a boundary. It's not part of the solution. Okay, so there's step 2. Graph the line. Dashed line for plain inequalities, solid line for inequalities with equals. Okay? Oops. So there's our boundary line, y equals 2/3 x minus 1. And then now we got to figure out which half plane to graph. So how do we do that? Well, there's 2 ways you can do this. One trick, it's a pretty good trick, is if this is written in slope-intercept form, if we have the inequality in slope-intercept form, which they tell us to do every time, okay, then think what this means. We want the y values that are less than the boundary line. Y is a vertical variable. So what's implied by y is less than? Then if y is a vertical variable, where would y be less than something? Below it, sure, because we're talking vertically, right? So less than vertically means below, doesn't it? Less than horizontally would mean to the left, right? So we're just going to be shading below the boundary line, and here's what we get. We're just shading that entire half plane. Okay. There is another way that we could check for solutions, which is a little bit more general. We could just test a point, too. We can always pick a test point. Because think what it means to be a solution. The set of all the solutions, what we call the solution set, is the set of every ordered pair that's going to make this inequality true. right? So if I wanted to test which side of the boundary line I'm shading, I could pick a simple test point, like what about the point right here at 0, 0? I could test that point. If I plug 0 in for x and 0 in for y, I'm going to get 0 is less than 2/3 times 0 is 0, isn't it? So 0 is less than -1. True or false? False. That is false. So that's telling me that the point 0, 0 is not a solution. So I'm going to shade away from that point. I'm going to shade the opposite half plane then, because that one should not be a part of the shaded half plane. Does that make sense? Okay. But we don't have to do that if it's in slope-intercept form. Especially for an advanced class like this, I don't think you have to put this into slope-intercept form. I don't think that's necessary. We'll look at another example where we don't do that. Okay, what about one like that? What's my boundary line going to look like this time? Solid line. Well, solid line. Okay, good. So what describe the boundary line? Okay, people are making vertical sign at x equals 2. So this time we just have something like that. And which side am I shading? To the right. I want the x values that are greater than, and x is a horizontal variable, so therefore we're shading everything to the right. That's not what I want. That's what I want. Everything over there. Okay? What about one like that? Compound inequality. What do you think that's going to look like? We'll do more of these later. What do you think? We'll come back to that one. We'll come back to that one just a little bit. Okay, what about this? So do we have to put this into slope-intercept form? We don't. We could. What would it give me if I were to put this into slope-intercept form? What would I get? Y. If I isolate that y, see if you can do this math in your head. What's that going to do? Okay, so I'm going to have less than or equal to, what's going to be the coefficient of x on this side? Good, -5/3, right? Because I'm going to have the -5x, I'm going to divide by 3, and then plus 4. So I certainly could do it that way, right? I could write the boundary line in slope-intercept form, and then this part right here is telling me that I would be shading below, right? Okay, but we don't have to go through that hassle. We could just do this with a test point and graph it using our cover-up method also. So let's find the intercepts. This is good review. So the x-intercept is going to be where? If I write it as an ordered pair, what coordinate do we already know for the x-intercept? Before we even do any thinking, if it's an x-intercept, what's y equal to? 0. Okay, so we already know we've got 0 for y. If I cover up the y term and solve for x, what do I get? I let y equals 0, solve for x. Not very convenient, is it? 12/5. Everybody agree? And what about the y-intercept? We know in this case if it's a y-intercept, we already know x is equal to 0. If I cover up the x term, I get y equals 4. Okay. So we could just use those 2 points and graph the line that way. So 0, 4 puts us right there. 12/5, 0. 12/5 is what as a mixed number? 2 and 2/5. 5 goes into 12 2 times with 2 remaining. So 2 2/5 puts me over about 2.4, right? So right about there-ish. What kind of line? Solid or dashed? Solid, because I'm including the equal sign, right? So we got to go solid. And now, which side to shade? Above or below? Okay, this time we didn't put it into slope-intercept form, right? So we could just test a point. That's one thing we could always do. What if we test the point? Let's pick the easiest one we can that's not on the boundary line. Well, that would be the point 0, 0, wouldn't it? Plugging 0 in makes things really simple. So if we test 0, 0, what's the outcome? If I plug 0 in for x and 0 in for y, what do I get on the left side of my inequality? 0, right? So I get 0 is less than or equal to 12. True or false? True. So I'm including 0, so I'm going to shade towards 0, right? Okay, so there's one way we could do this. How else could we do it? Well, even if we didn't put it into slope-intercept form, we could anticipate what the sign is going to be here, couldn't we? Right? Even if I didn't do all this work, does everybody agree if I'm going to isolate that y, I'm going to isolate that y there, I'm going to end up with y on the left side. I don't have to flip the inequality because I'm dividing by a positive 3. Everybody see that? So I'm going to get y is less than or equal to, you know, whatever, right? It's less than or equal to the boundary line. So I could just mentally do the steps to isolate the y, just trying to determine what's going to be the final direction of that inequality. It's going to be y is less than or equal to, so that's telling me I shade down. Take your pick. Either one of those methods is fine. Any of those 3 methods would be fine. Okay? How are we doing? 1 to 5. Okay? Let's try another one. Why don't... We're going to get some more practice with, when we do the systems, I might have you guys do one of those on the board or something, get a little board work practice. Okay, what about this? Let's try an application here. So Stephanie spends 10 cents per text message sent and 25 cents per picture message. This must be old. Picture message sent on her cell phone. Her monthly budget for messaging is $30. Okay, we want to write a linear inequality to represent this situation, and then we're going to graph it. Okay? All right. So, how could I do that? What do you think? What are the variables here? What are the things that can vary? Unknowns, variables, same thing. Okay, and by picture message and text message, what about them? Okay, there you go, number of them, right? Number, good. So number of picture messages, number of text messages. Let's just let x equal number of texts and y equals number of pics. And then how could we come up with an expression for the amount of money she's spending on texts and pics? What's her total expense going to be for her, the total cost of all her text messages and pictures? Okay, good. So we know it costs 10 cents per text, so the total cost for all the text would just be 0.10x. It's 25 cents per picture, so 0.25y, because y is the number of pictures. There's this represents total cost. And what do we know? Her cost is limited, isn't it? Say it again, Trey. There you go. Right. She's got a budget, so she can't spend any more than 30. She can spend less, right? But she just can't exceed her budget. So we've got then monthly budget is $30, so that's telling us less than or equal to 30. There you go. Okay. So we've got a linear inequality that we can graph now. Let's do this one just by, how about the cover-up method? Let's just do that. So if I want to find the x-intercept, or the y-intercept, I'm going to cover up that term and solve for y. What's that tell me? If I'm trying to find, I'm just trying to find the boundary line now, right? So I'm really looking at the line where this is an equation, right? The boundary line, let me write that down. So the boundary line is going to be 0.10x plus 0.25y equals 30. Okay, so we're covering up the x. What do we get for y? 30 divided by 0.25. Same thing as 30 divided by 1/4. You divide by a fraction, you multiply by the reciprocal. So what do we get? 120. Yeah, makes sense. $30 would be how many quarters? 120 quarters, wouldn't it? Okay, so we've got the ordered pair then. X is 0, y is 120. How about the other intercept, the x-intercept? If I set y equal to 0 and solve, 0.1x equals 30, what would I do to isolate the x here? How could I undo multiplying by 0.1? I could divide by 0.1, or what could I multiply by? How could I make that an x? 0.1 times what is 1? 10. There you go, right? Okay, good. I could multiply by 10 to move that decimal point one place. And so I'm going to get the other intercept is going to be at, what's that going to be? 300, 0. So I don't know what this scale is supposed to be here, but it's not a very good scale for us. I guess we're going by, what are we going? We're going to go by 30s. Okay, so we could go 0, and then that's going to be 30, 60, 90. There's 120 right there. So there's one intercept. And then if we go by 30s down here, I've got, there's 30, 60, 90, 120, 150. I'll go over 5 more. 1, 2, 3, 4, 5. And there's 300. And we want a solid boundary line, right? Because I'm including the equal sign. Are we shading above or below? Below. How do you know? You're right. True. That's a true statement. What about algebraically here? How would I know that I'm shading below? Hayden, if I were going to write this in slope-intercept form, what would this become? If I want to write that whole thing in slope-intercept, I'm going to get y is what? Okay, but what's the inequality going to look like there if I isolate that y? Is it going to flip? It is going to flip? You're right, it's not going to flip, is it? I'm going to subtract that term to the other side, and then I'm going to divide each side by a positive so it does not flip. Everybody see that? So I know I'm going to get something like y is less than or equal to whatever the boundary line is. We don't even know, right? But we could figure it out. We've got 2 points, though, so we can already graph it. We want to be shading below that, though, so there's our inequality. Oops. There it is, everything below. Okay. So all those ordered pairs in there represent solutions. So for example, if I take this ordered pair right here where I go over, say I go over 90 and up to, I'm at this point right there that has coordinates 90 60. So 90 text messages and 60 pictures would be fine, because that's inside the solution set. That's within her budget. But if I pick something up here like this, if I go over 150 and up to 90 on this axis, she can't afford that. That's outside of the shaded area. It's not in the solution set. Okay, give me 1 to 5. Okay, all right. So the next step then is, what about a system? Well, a system just means more than one at the same time, right? So if I'm doing a system of 2 linear inequalities, I'm just going to graph them both, and we're looking for the intersection, right? But this time the intersection is a little more complicated. When we had a system of 2 linear equations, we had 2 lines, the intersection was pretty simple. It was just the point of intersection, right? It was a single point. But this time, the solution set could be a heck of a lot bigger than that, because we're trying to find the solution between shaded half planes and boundary lines. So it's going to be the multiply shaded region. So let's find both of these then. Let's take this first one. This is going to be red. How about? Okay, we could, and you guys, you know how to graph this, no big deal. I start with the y-intercept. Where is that? -1. My slope triangle is telling me to rise how much and run how much? Gavin, how much am I rising from my y-intercept? For this line right here, I'm starting at -1. What am I doing? Good. Down 2 and over 3. Very good. Create a second point. Solid or dashed boundary line? Solid. Good. Okay, Ella, am I shading above or below? Does that make sense? Below? Because of that, right? That's telling me down. Okay, so here's... Everybody agree there's my first inequality? Good. Okay, next one. This will be blue. Naya, help me graph that. Where am I starting? -8. So that's, what is that? Well, that's right there. And slope triangle. What's my slope triangle going to be, Grace? Go ahead, Grace Pittner. Go ahead. Up 1 over 2. Very good. So there's another point. Solid or dashed boundary line. Ashton, what's the verdict there? For this guy? Say it again. Solid. Good. Yep. Got an equal sign, so we're including boundary line. There it is. Shading above or below. Jack, what's the verdict there? For this one? Above. Good. We can tell from that, can't we? We want to know, where is y greater than or equal to my boundary line. So y being greater than is above. So we've got something like this then. Right? So what's the solution going to look like this time? Yeah, it's going to be everything. Did everybody see down here? It's going to be all this place that is both red and blue at the same time. Okay? Am I including that boundary line? Yeah, good. Good. I'm seeing lots of head shaking. That's right. I am, because it's solid. Am I including that boundary line? Yeah, that's both red and blue also. So if we want to kind of highlight what our solution set is then, it's going to be this part right there, isn't it? There it is. Okay? All right, Desmos does something really cool with this. I don't know if you've ever tried this before, but if we go into Desmos, does an excellent job of graphing linear inequalities. Okay, so let's try this. I'm going to graph both of these. I'm going to graph this first inequality here. Y. Now, how do I get less than or equal to, do you suppose, in Desmos? Okay, all you do, you type less than followed by equals, and it combines them. Less than or equal to. Negative, pretty cool, negative 2/3 x minus 1, and look what you got. Okay, notice it creates a solid boundary line, it shades below. Same thing here. Y is greater than or equal to 1/2 x, whoops, 1/2 x minus 8, and there it is, right? Isn't that just what we said? Right, there's my solution set. Now, if I want to know some important boundaries, I can still do all the old tricks I could do. I could find points of intersection. I could find intercepts, if that's helpful. Okay, make sense? Okay, and so here's, I think I left a little picture of this on the notes. Right, there's what it looks like. One really nice thing about this is I don't have to have my lines in slope-intercept form. I could go in here, for example, and I could just leave it in standard form like this. Let's do this first one. So I get 7x plus 3y is less than or equal to 18, and it's fine with that, right? It doesn't have to be solved for y. Now, on the graphing calculators, on the TI-84s, you do have to isolate y. Okay, how do you do this on the graphing calculators? I'll show you that too. Okay, so on the graphing calculators, I would go into the y equals menu. I'm going to turn off my plot, and I'm going to go ahead and clear this earlier line. I would have to isolate y. Now, you guys are smart enough, you're good at algebra, you could just, what I call, solve this into the calculator, right? So if I want to solve for y there, it's helpful to use the little fraction template. So I'm going to hit my shortcut, alpha, and then I think it's F1. Yeah, there it is, alpha F1, enter, gives me a little fraction. So if I'm isolating the y, what's already on the other side that's going to be in the numerator? Well, 18 is already there, right? What else am I moving over to the other numerator to get the y by itself in that first equation? Yeah, I got to subtract the 7x to that side, right? So I get 18's already there. I'm going to subtract 7x. Oh, darn it. I didn't mean to do that. Shoot. 18 minus 7x. And then I'm going to isolate the y, I'm going to have to divide the whole thing by 3. And so there it is. Now, how do I show this? Okay, so I go over to here, and I think now, what do I do there? I think I can turn that into, on these new ones, I think I can go math. It's been a while since I've done this on here. I go math, and then I go number. Oops. Math, number. Is that right? Nope. Oh, I know where it is. Never mind. I know where it is. It's not there. It's on. It's down here. It's on the test menu. That's right. So I go second, test, and there it is. Now I want it to be less than or equal to, so I'm going to choose 6. Okay, it's not letting me do that. What is going on now? Okay, there's another way to do this one. I'll show you another way. I thought the new system would let me do that, but it won't. So here's the other thing you can do. you can go into the apps and you want to use something called Inequalities. If you don't have that, you need to get that. I can pass it to your calculator. If you bring, how many people have TI-84s again? Okay, check yours. Okay, yeah, so we can do that too. I can update the operating system for you. So if you need it updated in any way, we can do that during a day when you guys are working or something. Bring them in and I can get that done for you. So you want to get Inequality. I'm going to go down to Inequality and I'm going to choose that. Then I think I just type any button here to keep going. Is that right? Yeah, press any key. Okay, now in Inequality, I can choose to change that. Boy, how did I do that before? It's been so long since I've done this. I think I go alpha. Maybe I have to use test again. I can't remember this. It's been so long since I've done this. Oh, there. Okay, let's try this. So I'm going to try 6 again, see if this works. It does not. Well, I'm going to have to study up on that because I can't remember how to do it on here. I thought I could, but evidently not. Yeah, I don't know how that works. Oh well, I'll show you that next time. You're going to use Desmos, I'm sure, anyway. Desmos is a little bit easier to use. Okay, so let's try one more of these. Now let's set this system up and we'll cheat and use technology to graph this thing. So how much time we got? 4 minutes. I was going to have you guys do this on the board. We'll do it tomorrow. Yeah, we'll do it on the board tomorrow.